Now next one is electric field at the end-on point due to a dipole. Okay, first of all, what is called a dipole, electric dipole? That is two equal and opposite charges. Two equal and opposite charges. Suppose this is plus q, this is minus q, separated by a constant separation, which is actually called effective length. That is called electric dipole. Okay, so let this be the center point of the dipole. Let this distance be L. So this distance is also L. That means the effective length is 2L. That is called the effective length. Okay. So now effective length 2L into magnitude of any one charge, that is called P, the dipole moment. That is called dipole moment. Okay. So now what we can do, end-on point means the point which is here, that is along the line joining the two charges. Okay, at the extension of the line joining the two charges, this point is actually called end-on point, or it is also called axial point. End-on point or axial point. Let this point be at a distance r from the center. Okay, from the center, let the distance be r. So we want to find out the electric field here. So first thing, we have to put a +1 coulomb charge, unit positive charge. At any point, if you want to find out electric field, the definition is force experienced by unit charge. That is, we have to put +1 coulomb. So this plus and this plus will repel each other with E1, and this minus and this plus will attract with E2. So therefore, net electric field E net will be equal to E1 minus E2. Because this is more, because the distance is less, E1 is more, and this distance is more, so therefore the force will be less, E2 will be less, so the net electric field will be E1 minus E2. Now in between these two, what is E1? It will be 1 by 4 pi epsilon naught into Q into 1, that is Q by. Now this total distance is R, this is L, so this much will be R minus L, that is R minus L square minus this two, in between these two, it will be 1 by 4 pi epsilon naught Q into 1, that is Q, divided by, now this is R, this is L, so total distance will be R plus L square. So therefore, Q by 4 pi epsilon naught common out, it will be 1 by R minus L square minus 1 by R plus L square. So therefore, it will be Q by 4 pi epsilon naught. The denominator will be R minus L, R plus L, that is R square minus L square whole square. And in the numerator, there will be R plus L square minus R minus L square. That means it will be A plus B whole square minus A minus B whole square. That is in the formula 4AB. So therefore, you can write here. So we can write here E net will be therefore, E net will be therefore, it will be equal to Q by 4 pi epsilon naught into 4RL, 4AB, and in the denominator R square minus L square whole square. So now this 4 can be written as equal to 2 into 2. And this R is given to this 2, and this L is given to this 2, and this Q is given to this 2. So therefore, it becomes 1 by 4 pi epsilon naught. It will be 2R into now 2LQ. 2LQ is P. So we can write P by R square minus L square whole square. So this is the expression for E net at the end-on point. Now here, if R is much greater than L, that means if this point is far away, or you can say this L is very small, that is called short electric dipole. For short electric dipole, So therefore, for short electric dipole, this E net will be equal to 1 by 4 pi epsilon naught. It will be 2RP by this L we can neglect, so it will be R square, that means R to the power 4, and this R and R4 if you cut, so it will be R cube. This is the special case.